Hey guys, in the previous video, I hope you are clear about the queues. You know how to perform NQ and DQ operations in queue. Those are the basic insertion and deletion operations as far as queue is concerned, linear queue is concerned. Okay, so let's write a code to actually do that. Okay, so this video is all about performing NQ and DQ. NQ means inserting an element and DQ is deleting an element. Just for a reminder, I'm saying it again. So first, let's have a clean code. Okay, so I'm starting from the very first line so that you will get a very good idea. Okay, so hash include stdio.h and I'll be having the void main, of course. Then first, let me declare the queue. Okay, as an array. So int queue. Let it have elements, sizes. Uh, Let me have a preprocessor directive, guys. You know what is a preprocessor directive, right? Hash define size and let me define it as 30. Okay, so you can just use the size variable here. Okay, it's a preprocessor directive, which means whenever you say hash define, uh, if you use the variable name size in your throughout your program, whenever you use size, that will be replaced by 30, guys. Okay, so int q of size, which means int q of 30. Okay, so here I should also give capital letters because the people usually go for capital letters whenever they talk about preprocessor directives. Okay, I think this would work fine. And after that, let me go for the top and rear variable. Both should have the value -1. Please remember this because the queue is empty now. Okay, and for enqueuing you have to use the rear end. For dequeuing you have to use the top end. Okay, top means not top, actually front, right? So let me go for meanwhile, let me also define those two most important pointing variables. One is front -1, which should have a value -1 because initially I told you the value is -1. So front end is used for dequeuing mostly. Yeah. So rear end will be used for enqueuing. To insert an element, you have to use the rear end, and you delete an element, you have to use the front end. You know that, right? All right, so let me define the two functions, two important operations, void enqueue. And if you want to insert an element, first you have to get that element, right? I'll say int lm. Okay, so here I have to define the function, and I'll say dequeue. It doesn't need to get any element, okay? Because dequeue means you just increment the front by 1. Okay, delete the first element. That's what we mean by dequeue. Okay, so enqueue only for the for the operation of enqueuing only, you have to get the element because you want to insert that particular element into the queue. All right, so let's check whether the queue overflow condition. Okay, whether you have to check if it is an queue is full. Okay, how to check that? If rear equals to size -1. All right, why it is size -1? Because rear starts from 0, right? Rear starts from 0, so size may be 5. Okay, if the size is 5, then rear will have the value 4 maximum because rear starts from 0. Okay, size means you are counting all the elements, so you have to subtract 1 from size to check whether the queue is full. If the queue is full, just print up queue overflow, actually, sorry, queue overflow. All right, else you just want to push the element. How to push the element? It's very simple, guys. Just increment the rear and assign it. That's it. Okay, if you are watching these videos from this tag, then it's very simple for you. Just increment the rear and assign the value. That's it. Q of rear equals to the element that you want to push, right? You have to check one more condition, whether front is equal to -1, which means that whether you are entering the first element. If you are entering the first element, make front also 0. Okay, this condition will work only for the first element because if the queue is empty initially, if the queue is empty, and if you are pushing the first element, the queue is empty, assume that if you are pushing the first element, then you have to check this condition whether front, because if the queue is empty, then front value is -1, right? So you have to make it 0 to ensure that the queue is empty and you are pushing your very first element. And for second element and third element, this condition will not be satisfied because front will be 0 by default. So this is just to just for the very first element. Okay, I think that will do. NQ is done already, so it's queue overflow. If it is not, then you can go for the exact algorithm. Just increment here and push the element. That's it. And go for DQ. DQ means first you check whether front is -1, which means the queue is empty. So you can't DQ any element. The queue is empty. So I'll say queue underflow. Alright. So else you can just increment front. You can just increment front. Alright. That's it. Okay. You can just increment front and it will DQ the first element. Here I can go for that. I can say void main. I can just execute these functions. Okay, I can just call these functions here. Okay, so from the user, first of all, let me get the size of the. Okay, size is 30. I've assumed that. Okay, but let me get the size. Number of elements that user wants to enter. So enter the number of elements. Okay, and let me go for a do while loop. Okay, a menu driven program. You know what is menu driven program? We have seen this, right? So I'll say c equals to 1. Okay, just the choice variable. So I'll declare that here. I'll make it c equals to 1. All right. So I'm gonna give choices for the user. So the first choice is whether you want to enqueue, whether you want to enqueue, and the second choice is you can dequeue. All right, or you can display. Okay, you can display the elements. You can do whatever you want. All right. Then this is not necessary. Number of elements is not necessary if you are going for a do while loop. If you are going for menu driven program. Okay, then scan the choice. Okay, scan the choice percentage d and choice, right? Store either 1 or 2 or 3. Okay, let me declare a variable for that choice. Right, so go for switch case. Okay, switch choice, you know the condition matching, right? Okay, if this is matching with any of the cases, then that particular block will be executed. So I'll say case 1 where the user wants to enqueue something. So let me get what he wants to push. So enter the element which you want to push, which you want to enqueue. Enter the element to enqueue. Enter the item, right? Uh, so he will enter something. Let me say that is let me store it in a temporary variable. Doesn't matter, right? So let me declare that also. Okay, and I'll pass the temporary variable to the enqueue function which I have already defined. Okay, and then let me break this. That's it. And case 2 printf. Okay, case 2 is very simple. I think enter the element. Okay, case 2 is dequeuing, right? So just call the dequeue function once. That's it. Okay, dequeue. All right. So break it. Case 3 is display. So case 3 and call the display function and let me define it soon. Display function, and because third option is display, that's why. All right. And default would be if you some invalid choice. Okay, default means none of the cases got true. User may enter 4 or 5, something different from this choice is given. So by accidentally, in those cases you have to print invalid choice. All right. So I think that's it. The only thing is missing here is, I think I have to print, do you want to continue? Do you want to continue? One yes, I will be giving 2 choices or no. All right. So if you want, let me store that in C, because if he enters 1, then C becomes 1. The loop will be executed again. If he enters 2, this condition gets false. Come out of the loop. So stop it there. Okay, because the user doesn't want to continue. C, right? So modify the C, because C is something which controls your loop. That's control variable which controls your loop. Okay. If he enters two, that means he doesn't want to continue. So it will be having two. This condition will not be satisfied. It will come out of the loop. All right. And yes, the only thing remaining now is I'm gonna define the display function, and I'll make some changes here, guys. So whenever I am pushing some element, I'll just print here. Okay, I'll just print I have pushed, so that I'll only by then I'll know whether I am pushing or not. So I'll say pushed percentage d, percentage d, and I'll say q of rear or lm, whatever it is. All right, and popping, I'll say that again. So pop, sorry, printf popped, just informing, right? Then only I'll be knowing that I have pushing and popping. Now popping is successful and pushing is successful, right? Popped percentage d, of course that's a format specifier, percentage d, and I'll say q of front element I'm printing first and I'm popping it there. That's it. And one more thing, I have to use the display function. So void display. Okay, you can display. It's very easy, guys. You start from front equals to 0, or else you start from the front value. You can go up to, like, you can start from the front value, and you can go up to whether front is equal to rear. Let me say like this. Hold on, because front is equal to rear is the last set of element, right? Last element. So I'll say while front is not equal to rear, front is not equal to rear. Okay, because when front equals to the rear, that's the last element of the queue. Okay, understand that. So I'll just printf the elements. Okay, percentage d and q of front. Okay, and I'll just increment the front. Okay, so what I'm basically doing here is I'm just popping and printing the displaying all the elements. Okay, so of course q front will be manipulated, and you can't, once you display, you can't get the q again, but of course you can store that in a temporary variable. You can do stuffs like that, but let me go very simple. Okay, what I'm doing here is I'm just using the front to iterate the loop. If front is not equal to rear, okay, of course if it is not equal to rear, you can iterate the loop. You can print all the elements at one stage. The front will be equal to rear, that is the last element. You have to stop the loop here. Of course last element will not be printed. What I'm saying here is at that last element, front is not will be equal to rear. That element is not getting printed, right? So let me print that separately. Let me print that separately. All right. I hope you understood this. I mean, it starts from a front value, guys. It starts from a front value. Iterate the loop. You increment the front value, iterate the loop, and print all the values of the queue. At one stage, front will be equal to rear. You know that, right? At that stage, the loop will start executing, but there is a value, right? There is a value where front is equal to rear. Okay, so at that value will be printed by this printf function. Okay, if you want, you can just ignore this and you can make one more statement here. You can check whether front is greater than rear. That will also fine. Okay, it will go up to whether front is equal to rear. Okay, front is equivalent to rear. It will print up to that particular case, and after that, of course, front will be front will be greater. If that is the case, front will be greater than rear. That's not possible. The loop will stop executing. All right, let me run this. Yeah, I think that should not be semicolon here. That's the first error. Then q undeclared. Oh my god, I've declared it already. Hold on, I've declared it q. What happens actually? Oh, add it here. Let me not do this stuff. Yeah, size undeclared. So I have remote size. Sorry. Make it 30. 29, right? So that's just the hard coded stuff. You can manipulate that. You can also get that from the user. All right. So enq dq display. I just want to enq something first. One. Enter the element to enq 13. All right. You push to 13. Yeah, push to 13, or you can push 13 is not correct, guys. Actually, you should say enqued 13. Okay, it's not perfect, right? Pushed is not perfect. Of course, correct, but you can go for enqueued. And here you can because of instead of popping, you can say dequeued. Let's be perfect. Okay. 1, 13, enqueued 13. Yes, I want to continue. Yeah, it's working. It's again saying the choice. I just want to enqueue 10. I wish to continue, and I just want to enqueue 14. So yes, I want to continue. I just want to display all the elements. Hold on. Hold on. Front is less than rear. Okay, I have to give the true condition here, right? Front is less than rear. Sorry. Okay, only in the front is less than rear, the loop will start executing. If front goes greater than rear means, then the loop will not be executed. Again, you have to print the last element. All right. Yes. Enq again. Enq 13. Enq again. Enq 13. Oh, sorry, it's an invalid choice. Sorry, I have to give enq. So it's 1 enq 13. Yes. Now I'm just displaying all the elements. So you got 10, 13, 13. Those are the elements enqueued. You can see that 13 here, 13 here, and again a 13 here, again a 10 here. Okay. Okay. Let me delete one 13. Okay. Let me delete. You can't delete 30. 13. You can delete only 10. I'll just give dq. So dq 13. Okay, like that it goes on. Okay, so it works like that, guys. You can use this, you can display all the elements, you can enqueue and you can dequeue. Thanks a lot. I'll just upload this code. Please try it yourself and learn this. Okay, thanks a lot.